Okay, in the last chapter, we talked about programming timers. Now let's go ahead and talk about programming counters. And so we're seeing these various things that are the next level of functionality that we want to be capturing in our PLC. Let's start with the counter instructions. And programs counters serve the same function as mechanical counters. Every time the actuating lever is moved over, the counter adds one number. Resetting to 0 is done with a push button located on the side of the unit. Electronic counters can count up, count down, or be combined to count up and down. Although the majority of counters used in industry are up counters, numerous applications require the implementation of down counters or a combination of up and down counters. All PLC manufacturers offer some form of counter instruction. One common counter application is keeping track of the number of items moving past a given point. PLC counter instructions are similar to timers, except that they do not operate on an internal clock, but are dependent on external or program sources for counting. All PLC counters operate or count on the leading edge or off to on transition of the input condition. The counter reset instruction must be used in conjunction with the counter instruction. The counter reset coil is given the same address as a counter, and up counters are always reset to 0. Okay, I moved the graphic so I could see this whole, so we all could see the same thing. So the counter reset coil is given the same address as the counter that is to be reset. And PLC counters can be programmed to count up to a preset value or to count down to a preset value. The up counter is incremented by 1 each time the rung containing the counter is energized. The down counter decrements by 1 each time the rung containing the counter is energized. Okay, let's talk about up counter. So the up counter is used to count false to true transitions of an input instruction and then trigger an event after a required number of counts or transitions. The up counter instrument will increment its accumulated value by 1 each time the counter event occurs. Here is an example of what that would look for a logic 500 up counter program. Here is a logic 500 up counter timing diagram, so you can think about that. Here is a logic 500 counter file, which is file 5, and here is a nomenclature associated with that. For the status bits, we have the CU, the CD, and the DN, the count up enable bit, the count down enable bit, and the done DN bit. And so those are shown in this counter table in the figure below. We also have the overflow bit and the underflow bit. These are listed on the same table. And so you can pause the video and see a little bit more details about the ranges that those can have. We have also the update accumulator UA bit, the preset value PRE, and finally the accumulated value ACC word. All of these are listed on the same table. So we just walk through all of those fairly quickly. Here we have the logic 500 up counter instructions, the ones that we would be using. So you can be seeing those as an example. The timer / counter menu from the RS logic toolbar, this is what it looks like. CTU is a count up, CTD is a count down, and the HSC is a high-speed counter. So these are all possible things that we can be using from this type of a menu and implemented in our programming. Here's a PLC counter program used to stop a motor from running after 10 operations. And so that's something that we will could implement. Here we have a can counting program. So how many things have been processed? This is what the logic would look like for that. And here is the logic 5000 counter instructions. You can see what that would look like. I'm not going to go this into much detail, but you can go to the textbook to explore a little bit more details on that. For a one-shot or a transitional contact is often used to automatically clear or reset a counter. The one-shot can be triggered from a momentary signal or from a signal that comes on and stays on for some time. Stays on for one scan only and then goes off. It stays off until the trigger goes off and then comes on again. Off to on or on to off. The on to off traditional contact provides a one-shot pulse when the trigger signal makes an off to on transition. Conversely, an on to off transition contact provides a one-shot pulse when the trigger signal makes an on to off transition. The Logic 500 one-shot rising or OSR instruction is the input instruction that triggers an event to occur one time. So keep that in mind. The up counter with a programmed one-shot rising OSR off to on transitional contact instruction, and we're seeing that in this figure. OSR instruction is used to freeze rapidly displayed LED values. Closing the momentary push button PB will freeze and display the value at that point in time. So that can be a useful thing for diagnostics. Here we have an illustration of alarm monitor program. So I'm just going to go skip that for now. Next, let's talk about down counters. And so a down counter will count down or decrement by 1 each time the counted event occurs. Normally, the count down is used in conjunction with the up counter to form an up-down counter. Here would be an example of what an up-down counter program counting diagram might look like. And so we can see the accumulated value goes up and down. And so these would be the kind of things that we can be monitoring. And here would be the ladder program, the count up, and then the count down would be the things that we would be having in our ladder diagrams. Here are the count down instructions, and so the information to be entered into the instruction is the same as that for the count up instructions, but instead of counting up, we're going to be counting down. Here is the countdown counter instruction program, so you can look at that in more details. And here is the up-down counter program all on one slide that you can feel free to look over. Here is a continuous monitoring of items in process. So you can feel free to review that. I fix the text there, so the accumulated count of the counter continuously indicates the number of in-process parts. The program that provides continuous monitoring of items in process, and so this is what the ladder programming would look like for that. Okay, let's talk about cascading counters. And so depending on the application, it may be necessary to count events that exceed the maximum number allowable per counter instruction. One way of accomplishing this is by interconnecting or cascading two counters. So this is what it would look like, the up counter, the first and the second. And so here, this is how we can get that larger amount of counting going on. Here is a cascading counter for extremely large counts. And so this is another way that you can be looking at implementation. Here is a 24-hour clock program. And so you have the hours, the seconds, the hours, the minutes, and the seconds, each with their own counter. Here is a monitoring the time of the event program, how that would look like, just adding a little bit more to the previous slide. And so let's pause for a minute.